Thanks, Matt, and good afternoon, everyone. And thanks for spending time to learn about BluGlass today. My name is James Walker. I'm the Executive Chair of BluGlass, and on the call with me today is Jim Haden, based in the US, President of BluGlass. And we're here today to talk to you about BluGlass's product-focused strategy in the industrial laser diode space. For those that don't know you, we are a clean tech semiconductor company. We've been listed on the ASX for quite some time, and we've been focused on commercializing our unique RPCVD technology, which is a particular application in the semiconductor space. Over the last 2 years, we have deliberately focused on making a product as compared to other applications of our technology. And we focused on making a product in one market, being the fast-growing laser diode market. And we'll spend more time talking about that market shortly. That has led to changes in the team, adding laser diode experience and laser diode industry veterans to the team to help us on that product development roadmap and to make sure we get products out to the market in the near term. As a company, we are debt-free and have a significantly technically strong team, and I'll talk about the team in the next slide. So as you can see, we have a strong team in recent appointments of Jean-Michel Barry and Jim Haden. Both are based in the US, and Jean-Michel is an industry veteran and the founder of a company called Nibiru, which is one of the laser diode pioneers. Jean-Michel Barry joined us in May last year. Jim joined us in September last year, and I'll let Jim talk to his background in a moment. But when you hear his story, he's been in this industry from the start and has worked for many of the leading companies in this space and has helped develop products for them. And that was the main attraction for bringing Jim to us, is that the issues that we are working through to get our products to market, Jim has already solved in his previous roles. So very comfortable with the team we've developed, and that will continue to develop over time as we add more and more laser diode experienced people to the team. Next slide. So why laser diodes? So just over 2 years ago, we were working through our technology, which has multiple applications in multiple markets. And we decided to focus on one industry first, make sure we get commercial validation in that industry first, and then we can start to consider about taking that technology into other industries. After a review of all the applications of that technology, it became clear that our RPCVD technology has some unique applications and benefits if we focus on making products in the laser diode space. And Jim will talk more about those benefits later. But laser diodes for us became a focus because it's a high value, high margin, low volume industry. And that suits our technology and our current manufacturing facilities in Sydney, where we have enough capacity at Silverwater today that we can make enough components for laser diodes equal to $170 million a year. And that allows us to have the ability to capture significant market share as we release products to the market. We've also used that technology to demonstrate the first RPCVD tunnel junction laser diode, which will mean and allow significant improvements in performance of the laser diodes as we develop that into a product. And with that, I'll hand over to Jim to talk about his experiences and the industry that he's been working in the last 30 plus years.
Thank you, James. So as James mentioned, I've spent a career in this industry, starting at the company Spectre Diode Labs, which became STL and merged with JDS Uniphase in the year 2000. JDS Uniphase then became Lumentum. After leaving that company, I went to Coherent, which is a very large player in this industry. And after Coherent, I went to Enlight, was their chief operating officer for 5 years. Since leaving Enlight, I was a consultant and consulted at a few different companies. Most recent was at KSLD, or Kyocera SLD Laser, which is a GaN diode company. So I've seen a lot of the problems that plague that industry in many different types of lasers and laser systems down to components and chips. And those problems are very similar to what we see today. And so we're very confident that we're going to work through all of the issues that we've faced. I think the since converting to the laser diode space in 2020, the team has made great progress. As Jim said, we are in a very healthy market. From 2009 to 2019, the market added just over $9 billion. And that was a 10-year period. And you can see here that the market is expected to add another $10 billion by 2025, just another 6 years from the 2019 mark. So it's growing at a good pace, and that pace is accelerating. In that space, 2.5 billion is expected to be GaN. And so that is growing at a very nice pace. And the reason this is growing is twofold. One, there are existing lasers out there in the IR space, infrared space, that will be replaced by blue lasers. Blue lasers have much better absorption in metals and organics. And so it's going to allow faster and better processing of those materials. And also the wavelength is smaller. Blue is a smaller wavelength than infrared. So you could do finer detailed processing. So it will consume existing laser markets, but also the blue light and visible light and UV light is going to enable new processes that couldn't even be done before having these wavelengths. So twofold, taking over existing markets and then building up new markets. And with the product line that we are already working on, we see a path to US $735 million, which would be in the our serviceable market. We are going to focus on 3 verticals in that market: the industrial, scientific, and biotech. This is where we will start our product lines, and we'll be doing in the violet and blue colors to address this initially, and then eventually going into the green lasers. On the left, the industrial lasers, that's driven by target applications such as welding, marking, 3D printing. Customers include IPG Photonics, Enlight, Nuburo, Optical Engines, Sakertech, and others. These are for the types of processes that you would see in automotive lines, and especially in the markets where you have a lot of copper welding, like electrical vehicles and the batteries for electrical vehicles. In the middle one, the middle vertical, the scientific, the target applications are quantum computing, sensing, and spectroscopy, excuse me. The customer landscape here is Coherent, Toptica, Photonics, and others. This market is very interesting and growing market. For instance, quantum computing it could be the next generation of computing. So that's in its very nascent stages. The biotech is another exciting market where it could be used in sensing and sequencing. It could be used in photodynamic therapy, and also could be used in basically when you get into the UVs, into UV ranges, into sterilization and cleaning. Now, there are many economic drivers in this industry, but part of this is the customers are looking for cost-effective solutions that are easy to integrate. And laser diodes and other forms of lasers can be difficult for the customers to work in. The customers want to have something that's easy to use. And so they are continually driving for a cost-effective solution. And the more they have to do it, the more they push on the dollar per watt metric. So if they have to do a lot of work, they want lower dollar per watt. If we can provide higher brightness, because a lot of the work they do is to provide bright sources of light. So the more work that we do, the more they're willing to pay. So our roadmap is to drive brightness and to not do markets where like headlights and lights where you're doing white light, where they're purposefully reducing the brightness by putting it into a white light phosphor. And with these innovations then to conserve the brightness, another thing that the customers are looking for, which is a key to their customers, are the efficiency of the lasers. How much does it cost to run the laser? So the more cost effective we can make it, the better total cost of ownership for our customers down the road and their customers. And so with our RPCVD technology, we believe we have advantages of getting lower resistance in our lasers, which is going to mean less loss. And less loss means higher efficiency. Finally, all of this comes together, the customer integration with bright sources, efficient sources. It costs less for our customers to integrate, and it reduces their material, labor, and overhead in addition to the operating costs on the road. Now, our RPCVD is a technology that builds on the MOCVD technology, which is a faster way to grow than some of the alternative growth sources for lasers out in the industry today. And so it takes that kind of scalability with the benefits of a nitrogen plasma source. Much of the MOCVD for GaN lasers uses ammonia, which has a lot of hydrogen in it. And hydrogen is like poison to the gallium nitride lasers. And so if we can use nitrogen that doesn't have any hydrogen, because we have this RPCVD, it not only is cleaner and cheaper, but it also allows us to grow lower resistance, as referred to on the previous slide. That lower resistance means lower loss, and it provides a path to higher efficiency, higher performance. The next thing with lower temperature growth is we can design novel structures that will allow us to have patterns and other things in the wafer, while we're doing growing the laser on top of that. And that will allow us to do architectures that are not available at the extreme high growths that gallium nitride is typically grown at. So the year ahead, we have a clear product roadmap, and on the left of this, you can see we have 3 colors. We've already delivered in violet, and we have development in the middle in both violet and blue. And in the next generation, we're going to go to higher powers in the blue, as well as extending our wavelength into the green areas. And this spectrum is also basically driving interest in the market. We have at Photonics West, we showed the violet that we've demonstrated, and customers were very excited about that. They were also excited about our roadmap, and it led to interest in what we can do from not just the violet, but even into the UV. Customers are already engaging with us and asking for development plans and roadmaps. And then all the way out into the green areas where some of our competitors are not willing to play at this moment, and we are. And it's because of our RPCVD technology that we are interested, willing, and able to work there.
Great, thanks, Jim. So as you can see, we are focused on getting products out to market as soon as we can. We're focused on getting the products out in the 405, the 420, and the 450 nanometer wavelengths, because we know we can have significant impact in those markets because of the advantages our technology offer. And customers are already engaging with us, waiting for us to have products in the market. We've expanded our team. We've brought in industry experts in the laser diode space from a product development, manufacturing, and corporate point of view, as well as good, strong customer knowledge. So when we have products, we'll have customers waiting for those products. Our clear technology advantages have led to a strong roadmap where we're able to articulate what industries we'll be able to play in and why we'll have advantages. And as we said, we expect to get products out to the market in the near term. And we already have customers waiting. So we need to get those products out as soon as we can. Over the longer term, our RPCVD tunnel junction technology will allow us to have significant advantages over the current products in the market. We'll be able to produce brighter products that are more efficient and have better performing specs in the blue GaN laser diode space. And as Jim's already talked about, the blue to green is a fast growing area in this space. So we're excited about the opportunities we've got. We're excited that we're focused on the laser diode space because we know we can have a significant influence in that market. And we're looking forward to getting products out to the market in the near term.